Now let's spend some time actually trying to define artificial intelligence. And we'll begin, of course, by conceptualizing intelligence, or at least having a brief discussion on how we conceptualize intelligence. Let's start by this idea that experience is really an abstraction, or at least this is where I begin, right? When I think about the world around me, I am thinking about my experiences. And so when I explain my experiences to you, really I'm abstracting the world around me and conveying them to you in some way. In that sense, we can think about perception and experience as being internal. This is my subjective, this is my subconscious. And then externally, there's this sort of collective notion of what things are and these objective ideas about what is real and what is not. Experience really then can be thought of also as feedback among our sensors, right? I get all these facts from the world through my hands, through my tongue, through my eyes, as I interact with the world around me. And I use then that to then form a sense of what my experience of the world is like, right? The act of doing these things could be rationalized as intelligence, but it really depends on where you want to draw the lines, right? In this particular case, if we just look at what I'm doing with my eyes, my visual cortex is taking in data and it's processing this input, but the actual meaning making is happening elsewhere. My meaning making happens in my experience as an individual, which may be different from yours. And so it means that even though we both look at the same thing or both go to the same party or read the same book, we are having very different experiences of the exact same external thing. It makes it really hard to decide whose experiences we're going to value more, who is correct, who knows what the right answer is. And when you're really thinking about what it means to actually conceptualize intelligence and codify it, right, put it into code, it means we actually have to come to some agreement about what we are seeing, right? Not necessarily what it means to be human and those larger esoteric ideas that we talked about earlier, but even just a simple case of how do I communicate to you that I want to eat something? Or that I want to go find some food. There are so many different ways, even within living things alone, that we could conceptualize that same concept. And so it becomes really difficult when we're starting to think about how we actually want to communicate this in our code. Rene Descartes talks about this idea of the mind-body problem, right? And you can think about this as a relationship between the sort of mental realm, the realm of thoughts, beliefs, pain, sensations, emotions, and the very physical realm, right? Matter, atoms, neurons. Let's think about this idea in the context of human vision, right? We have eyes, we have all these different sensors, but in a lot of ways, we're perceiving things in the world that are far away from us, right? Even though I can open my eyes in the morning and see a cup of coffee, and there are all these other things happening, I'm not seeing it just because my eyes exist. Something in my mind is actually processing that information, right? There's a visual system that is conveying to my awareness the cup of coffee or the image of the cup of coffee. And at some point, I'm deciding this is delicious. I'm going to drink it. So what does this mean when we're designing artificial intelligence, right? It goes back to that idea of everyone's experiences are different. Everyone is seeing and listening and learning to different things. And so if we're trying to recreate human experience as a generic concept, it becomes really hard for us to sit down and agree on what we're actually going to codify. This includes things like our emotions and our feelings and our ideas about the past and the future, right? So really the question is, are we trying to build tools that happen to mimic human ways of being? Or are we trying to build tools to accomplish specific things, right? This is one of the larger questions that we will have to deal with as we're trying to think about what it means to actually design the artificial. Let's look at a very specific example. So this is Lexica Art. It's a generative AI system, which means that you can put in a prompt and it is using different kinds of information on the internet. And then it is mimicking, in a lot of ways, a human style of creating art. So when I put in the prompt, please create a surreal painting in the style of Dali depicting the concept of a bicycle for the mind, the painting comes out like this, right? I ask it to consider these different things, but in a lot of ways, what it's doing is it's taking my language, contextualizing it in both, the style of Dali, as well as a couple of other things that I had in there, and then providing this as an object for me to consider. Steve Jobs is actually the person that used the phrase, a bicycle for the mind, to describe the computer, right? In a lot of ways, as we think about what AI could be, I would like to encourage us to think about it more as a bicycle for the mind than necessarily a replacement for the mind. So let's now look at a couple of different definitions of artificial intelligence and see if we can come to some consensus on how we're going to use this for the rest of this course. In his paper, What is AI?, John McCarthy engages in this sort of didactic definition of AI, right? So when asked, what is AI? He says it's the science and engineering of making intelligent machines. And like us, he's led to that inevitable next question of, well, what is intelligence? What I like here, though, is he says, intelligence is the computational part of the ability to achieve goals in the world. Achieve goals in the world, right? If we just take that little phrase, that means we're now able to think about where we want to direct our technology to, right? What are we actually trying to accomplish and then design by thinking about the goals that we are trying to achieve. Russell and Norvig's book, Artificial Intelligence, A Modern Approach, is considered a fundamental book in the discipline of AI. I would encourage you to go check it out. But here's a very quick summary of at least how they describe how AI should think and act, right? If you go back to the earlier discussion we were having, that was a lot of our discussion earlier was thinking about this human approach, right? Designing systems that think like humans, that act like humans. But really, we might not necessarily want to mimic ourselves, right? What we really want to try and think about is what is the rational way of doing things. And so they describe this ideal approach where we design systems that either think rationally or act rationally. And the question mark is there because it still means that we have to come to some consensus on what it means to think rationally as well as act rationally. So no matter what we do, whenever we are writing code, we are always having to come to consensus on what we think the right way of doing things are. And even if we can't come to consensus on whether or not it is 100% the perfect right way of doing things, we should have a mechanism, and we will explore this later, on how to actually demonstrate the assumptions and constraints that you use in order to then say, well, within this realm of working, this is what I think is rational, right? So that idea of design constraints will come back up again later. The most practical definition, I actually really like this. It comes from a little IBM Explainer article, and it talks about the different disciplines that we will build on, right? At its simplest form, AI is a field which combines computer science, data to enable problem solving. Right? As we go through the rest of this course, we'll touch on concepts that, yes, come from philosophy and science fiction, but also from machine learning and mathematics and statistics and design and architecture and a whole host of disciplines that together allow us to actually think about different ways of writing AI algorithms and creating expert systems which help us achieve those goals that we talked about earlier. That could include, for instance, making predictions or classifications based on input data. So let's look at a couple of different types of AI. And I'll start with narrow AI, because this is where I argue we currently are. Narrow AI is a very task-specific tool, right? Alexa, the virtual assistant, is a classic example of a narrow AI tool. It doesn't do anything and everything. It, within its own domain, can allow you to perform a couple of different functions. Right? I can ask it to open an app on my connected device. I can ask it to reach out to another device on my little network and perform a task like, turn on the cameras so that I can answer the front door, and so on and so forth, right? It is very task specific, and this is currently where a lot of the tools that we're building are. A lot of the discourse, however, around AI, particularly sort of the fears and the excitement more broadly, is around this concept of general AI or AGI. When we were talking earlier about what it means to be intelligent, what it means to be conscious, what it means to be human, a lot of those ideas are things that we aspire to when we're thinking about creating, right, artificial intelligence that has a theory of mind. But this is very theoretical, right? And I want to be very clear about where this work lies with respect to the current state where we currently are, the task-specific narrow AI. There's also this even further out conceptualization of AI, and it's this idea of super AI or super intelligence. And this is very, very speculative AI, right? The examples that I gave in fiction, they live in super AI land right now. So even though there are some really interesting books and discussions around what it means to design super AI, I would argue that a lot more of our attention should really be spent on thinking about the right here, right now design goals around how can we actually support humans via potentially mimicry, but via many other means to achieve the goals that we have set out, as opposed to necessarily worrying just yet about how to create intelligence or create consciousness, so to speak. So with that in mind, let's think a little bit more. Let's double click into this idea of narrow AI. I'm actually going to introduce two concepts that are a little bit older. One's the concept of a general purpose technology, or a GPT. We've seen many different GPTs in our discussion so far, right? Sharp edge tools, printing presses, steam engines, electricity, computers, smartphones, and potentially even certain kinds of AI. The way in which you can describe or define a GPT is that there's a generic yet recognizable tool, right? So something like a search engine would be another example of a GPT. It's usually crude in the beginning, but you see it evolve rapidly in nature, and you might notice some of these in our world right now. There's oftentimes a set of wide-ranging applications. So even though I had said earlier that we should be interested in task-specific things, GPTs oftentimes have a variety of different applications. It's not to say that they're not task specific, but they're a platform for innovation. And so it means that they become really critical to societal function once you are able to then match those applications to specific tasks that people actually want to accomplish. On the other side of the coin, we have specialized technologies. These are often specific and very recognizable tools. There is an increasingly specific mapping between tool and task, and there's this specialized application, right? So it's limited to use by specialists, even if it's an electric toothbrush. Oftentimes, these become critical to a particular function or even unsubstitutable. But again, these are very, very task specific, even more task specific than many other things. And there's value to both types of technologies. Narrow AI can be either or, and that's a little bit of what I want us to explore in the next couple of lectures as we really look at what it means to actually create general versus specialized AI. Again, still living under that bucket of narrow AI. So the Roomba is a current example of an AI tool in action. It does one thing. It mops and vacuums your floor. So this is a specialized AI system. Siri, however, is a virtual assistant to control your smartphone and connected devices. Like Alexa, it is a narrow AI in the sense that it still works within its domain context, but it is a general purpose technology, right? It was not necessarily designed just for one thing. It's an assistant, virtually anything. But remembering again, the virtually anything is bounded by the domain within which it works. ChatGPT, I would argue, is also similar, right? It's a conversational agent that you use to query a limited subset of digital information, mostly public information on the World Wide Web. But again, it's not designed for necessarily a specific task. It is supposed to be a virtual assistant in a lot of ways. And so it means that it's still general purpose. And we're now seeing an entire ecosystem of tools being built on each of these that are increasingly more and more specialized. And again, we'll talk a little bit more about what some of these tools and tool chains can look like as we move through this course. So with that, I want to leave us with a charge of really focusing in on this concept of designing narrow AI, right? So thinking about our collective experience, understanding how we think, abstract, and experience to then really inform the specifics of what we design. I want us to think about this idea of really identifying goals and tasks in the world that we are trying to accomplish and thinking about the mapping of those goals to the things that we want to build, right? And so in a lot of ways, we want to think about designing narrow AI with implications for sort of these longer ranging goals around intelligence that we have.